So some of what we're going to talk about today really does also lead us down a rabbit hole of security. And so we talk about this idea of kind of a catch-all at the end of the semester. And one of the things we're going to talk about is this idea of a SCADA system. And when I say SCADA, we use those in all kinds of different commercial and business applications. So what we're really talking about is this industrial system. So things that allow us to function. And you think, well, I don't want to be in a factory. Where else is there? Well, almost anything. We use them in colleges. We use them in small businesses. And now that we have this other term that's thrown out called the Internet of Things. And that really means everything now has a sensor and they're connected into our network. So everything from thermostats to machines to controls on people. And maybe we monitor our people where they go in a building. And you think, well, I have a lot of employees. If they just wore a badge and I could see where they're at in the factory, or I now have cars and I can see where all those cars are. Maybe I run a heating and ventilation cooling company, and I think it would be really neat if I knew where all of those trucks were at so I could dispatch them better. Or I were Warner Trucking and I knew where all my trucks were. And so now that we can connect all those things, we really have this idea of this industrial systems. So we're getting all these pieces put together. And they don't necessarily have to be in one small location. So think about something like a pipeline. And certainly here in Nebraska, have we had a lot of discussion about pipelines? Yeah, the Keystone Pipeline, and there's, quite frankly, when you look at it, there's thousands and thousands of other miles of pipelines. But now we're thinking about, can we put sensors in those pipelines and see if we have a leak a lot quicker? Because the reality is, pipelines are the safest way to transport chemicals, liquid chemicals. But at some point they are going to leak. So how do we do that? How do we get it to the point where those sensors are accurate enough that we can do it preventively or proactively before something happens? So the Internet of Things is not just putting Alexa on everything in your house, but now we're starting to put those into businesses. And even to the point of, we deal with it in terms of traffic control. Why do we have street lights on? Why do we have traffic lights on if nobody's there? So think about it from that terms, in terms of saving money even. So now we're putting all these connections together. We have more data than we ever have. But from our standpoint, the biggest piece we have is, how do we start controlling it? And so one of the mechanisms to control all this data and not only just read the data, but actually make changes, is there are systems that we generically call SCADA. So supervisory control, acquisition of data. So we have these machines and we connect them together. And where we see SCADA a lot is in industrial environments. So if you go into a power plant, we have SCADA. If you go into almost any kind of public utility, so you go into water treatment plants, you go into any of those, you're going to see SCADA. Water treatment, sewer, all those kinds of things, you're going to see SCADA. If you go into a factory, you're going to see this idea of SCADA. And what it allows us to do is control components remotely without us physically having to be at each individual site or each individual machine. And so one of the things that these are based off of is something called a PLC, Programmable Logic Controller. So each machine has a little controller. So if I'm going to turn on a valve that lets water into the city of Peru, it's got a little PLC controller there, and I access it, and it goes, oh, I'm going to open the valve, and it turns the valve and opens it up. So PLC, you're going to see the term PLC, Programmable Logic Controller, when we start talking about those a lot. So SCADA is kind of the overarching piece, where you're also going to see SCADA, and we talk a lot about it in the cybersecurity class, because quite frankly, a lot of this original SCADA wasn't built with security in mind, because nobody realized that people would want to do bad things. And you think, well, how bad a thing can they do if all they can get into is the sewer treatment plant or the water treatment plant? Bless you. So they're in the water treatment plant. Could they change the water so it would actually burn your skin or burn you when you drink it? Yeah, very easily. So it's also a target, and we look at things like how do we control power and communications. Now we have to think about what kind of aspects of this in terms of security. And so we talk about that a lot in cybersecurity. So this is kind of a quick overview. You're going to have all these parts in general. Now sometimes it's very simplified and there really only is a control server, but in an ideal world we kind of separate out those functions, but a lot of times we build them all into one just for ease of use. So there's really not a lot to it. We go over the internet in a lot of cases. We can connect, we can turn on power relays, but we have to be cognizant of how easy these are to get into. So if I set up a SCADA system and I leave it where the login is admin, somebody can very easily scan the internet and actually find that very, very quickly. So we do have to be very cognizant of that. It's great. We have great, wonderful tools. We have to be able to come up with a way that we can control it. So here's a PLC plugged into some kind of a machine. Notice it's got a network cable. In some cases now we're even making those wireless, which adds yet another security issue in there. So wired is bad enough. Now we make them wireless. It's very convenient, but it also adds another layer in terms of how do we protect those guys. So a couple of really quick things about them. So typically they work in either open loop or closed loop. And your car does exactly the same thing. So your car, when it first starts up and it's got kind of that high idle, it's in what's called open loop mode. So based on programming, based on what's happened in the past, it starts up and gives it a certain amount of gas, a certain throttle position, and until it's warmed up and all the sensors are getting the right data and your catalytic converter's warmed up and it's getting the right data, it runs in what's called open loop. So in other words, we're not taking those sensor data and making any changes. Once it switches to closed loop, then we're taking real-time data. So what's actually happening in the car? So what does the catalytic converter say? What does the water temperature say? And we're making changes then based on those real-time events. Well, we do the same thing then when a lot of our industrial systems. We start up a water plant, and until we have all those decisions made and those sensors have come online, we're operating based on what has happened recently. So closed loop and open loop. Open loop means we don't have those sensor data. Closed loop, when you hear that term, that means we do have all of that sensor data filled in. And we can actually use it to make decisions. So the other way I always think about open and closed loop is, have you ever seen a football team run the same play 5 times in a row? 6 times. So I'm not Justin's like, yeah, I have. I've been on that. Because you're not taking the inputs. If you take the inputs from what happened on the result of that play and go, we need to adjust, that's closed loop. If you just keep doing the same thing because that's what we're programmed to do, well, we end up with the Huskers for this year, right? So what kind of things can we do to secure it? Again, we're going to look at this a little more in depth in the cybersecurity class, but a couple of things that really are critical. The first thing, and I'm going to throw them up in a little different order, is I want this network, my industrial control network, completely off the internet to start with. Because I don't know what's happening, who's in there, what. I'm going to pull the plug on it when I come in and say, we're going to secure this. And it's gone. And then I can start inventorying all those connections, because what I may find out is I think I've got it disconnected, and there's little tangles and connections that we didn't realize are there. So I want to come in and actually pull the plug, and sometimes that'll reveal that things are broken. It also may reveal things. I actually had a client who had a manager, And we pulled the plug on their SCADA system from the internet for a couple of reasons. One, the password, well, crap, for a password into a sewer plant was probably not appropriate. But what we knew from talking to employees, this guy didn't ever actually show up. He did all his work from home. Wasn't appropriate in that case. Is there a time that this SCADA is really great because we can work remotely? Yes, but not so he can go on vacations repeatedly. So in this case. So one of the things we did was we pulled the network and we said, we got to get out of here. What other things are tied in? And so that's that second piece, getting all those connections inventoried. How is it connected? Where is it connected? So we're mapping our network of that SCADA. And what happens over time, and a lot of times in those busy industrial settings, people add things. You bring in contractors and they add components and parts, and you don't even realize what's going on. How many places it's tied in now. So a couple of other things. We may segment it physically, or we may segment it via VLANs from our corporate network. And so it depends on how we are. So for example, at Cooper, those networks are completely separate. They're not even allowed to use VLANs to connect those. But at other places, depending on your security regulations and what you're doing, we can use VLANs and it'll work very, very well. And then we come in and we go, okay, now we know all this. We want to put pieces of it back on the internet, or we need to get in there. So we do things like a VPN into a single terminal that's got a connection to it. We have very strict firewall rules. We put in intrusion detection systems. We may have all different levels of how do we protect this. And so we want to put multiple levels in of protection between the outside world and our SCADA or industrial control systems. So we want to make it hard for somebody else to use it, but still maintain a little bit of that usability. From internally, it's still the same, but again, getting out. So, other things we want to do. We want to harden that network. So, encryption becomes important. Redundancy. So in a lot of cases, what we find is they're very critical systems and we don't have a redundant component, we don't have a redundant network path. So we need to figure out how we can do that. We need to make sure that those vendors that we use all the time don't put backdoors in our system. So if you looked at Target, and that's one we do talk about, Target a few years ago got hit for a lot of information, and what we found out, it was an HVAC controller unit that actually led to the breakdown. It wasn't somebody in the point of sale. It was because they were able to get in through the HVAC controller. And again, those vendors, you need to make sure, what are they doing? Why are they on my network? Why are they using admin as a password into my network? So, we also talk a little bit about something called a Faraday cage. So a Faraday cage is really nothing more than a metal mesh shield around the area that we need to protect. So Faraday cages are a way we can stop wireless signals in and out. And so you've seen the term probably in a lot of these TV shows. You can actually do the same thing with your passport. And in fact, if you have one of the new passports with an RFID tag and you don't have it in a carrier that will block that, then you can be read by about anybody. So Faraday cages just block those wireless signals. So we sometimes will put those around areas to protect or block. So depending on how big a network it is, sometimes, or luckily in the business world, when we have a big factory, they're usually in metal buildings, and those do a pretty good job of being a Faraday cage anyway. So here's some of the best ones. And they're the things we hate to do, and that's why they don't get done. All the documentations for that software, those pieces, those parts, all need to be documented. All need to be documented. And so when another vendor comes in, we can go, yep, here's our equipment, here's the specs we want. When somebody comes in for a security audit, here's my documentation. When something goes wrong with it and you need to fix it, here's my security documentation. So We also need to do things like backups and data. So it can be very, very expensive to bring in somebody to update SCADA. If you have to bring a vendor in to redo your SCADA system, you're probably talking $500 or more an hour to bring in an external vendor. It can add up really, really quickly. So make sure that we have that, and that's the biggest piece. And it's the part none of us like to do, that documentation. And we keep throwing it out there in all of this. We said when you build your network, document what's in there. Now we're talking about it when we say industrial control systems. Document what's in there. Document so you know what's going on. When you build a help desk system, keep documents on it so we know that which people are having issues all the time, what's going on with the system. That documentation is one of the keys to being to work around there. So when we talk about documentation, it kind of leads to this idea. Asset management. So we have more than a couple of devices. We need to manage what is out there on our network. So we have some tools available. And one of those, that Spiceworks we looked at, has an asset management tool. It can say, hey, I know that this node or this device is connected to the network, but it doesn't tell us what's involved. For example, what's inside the machine. We don't have asset management then of what's inside of a computer, for example. And you would think, well, you gave somebody a computer. But there have been a lot of cases where we've seen businesses where employees decided, you know what, memory prices are up this year. I'm going to take out half the memory out of every desktop computer, and I'm going to go sell it out on eBay. And if we don't have that asset management and some way to track what's going on, it's pretty hard to deal with. So, asset management. And we can also look at other assets. So if we build an asset management for our IT resources, we can also build resources for other things that we can monitor and look at. So we can easily through software look at every piece that's connected. And we can look at through like something like Spiceworks. We can actually look in a lot of cases at what software is installed, what hardware is installed. And you think, well, why do I care about software? If I run XYZ Corporation or I run Xerox and I have an employee that downloads an illegal copy of Photoshop, can that get me in trouble as a company? Very easily. It's hard enough to be license compliant. So we can also then, this allows us to move to sort of proactive. So if we're in charge of supplies, for example, a lot of these tools will interact, including Spiceworks, so you can get it to interact with copiers and printers, and it will actually look at how much toner's left or how much ink is left. And so you can preactively go ahead and order and maintain that. And so you can cut your costs down. Because if I'm ordering ink or toner in bulk versus ordering it every time some user goes, oh my goodness, I'm out of ink, I got to run downtown, you can cut your costs down significantly. So you can look at, the users here are almost out of hard drive space. We need to see why and what's going on. So it gives us a lot of benefits. So we can be proactive about what's going on. Sometimes we set dates in there, and we may say we're going to be on a 3-year or a 5-year hardware or software cycle, and that'll allow us to look very quickly and say, all right, I have 5 computers in the legal department that need updated this year. I have 4 in the management department, and I can look at that and create strategic plans so I can be proactive versus reactive to what's going to happen. And a lot of those devices will actually look at things in terms of proactive. They'll say, hey, I keep seeing errors on Kimberly's hard drive. And we can actually proactively then, before data gets lost, go out, copy the drive, swap in a new one. Well, we have some other business documents we need to deal with. And you're going to see these are pretty common. So RFPs. If you haven't heard the term RFP, you will at some point. So RFP says request for proposal. So we build it and we say, here we have an RFP. we need you to provide pricing or a service. So the last one I got involved with here on our campus was for Blackboard. So you guys use Blackboard. Do you guys have any clue how much Blackboard costs a year for us? A lot. So we're pushing $100,000 for the cost of Blackboard a year. That's a pretty good chunk of money. And so we actually look for competitors. And we actually looked at 5 different vendors, submitted RFPs. So we said, here's what we need, here's who can provide it. And actually, Blackboard was competitive in that bidding process. And they actually came out as the lowest price over in this case, a 5-year period. So they've presented that. And part of that then is that statement of work. So what are they going to do in there? And so part of that, we just had some training. They're going to provide additional training, what kind of updates. And once we have an RFP and we've agreed on it, we enter into some kind of a contract. And a lot of times that contract is called a memorandum of understanding. So it doesn't sound very binding, but it is a very valid legal document that says 2 or more parties, we're going to do these particular things. And so what it lets us do is we say, all right, here's our pricing. We're going to enter into a memorandum of understanding that this is the pricing we're going to pay for 5 years. This are the activities. And so generally that MOU has that scope of work in it. So these are kind of a piece that are in there. Inside of there, you may see a lot of other terms that you're going to run into, but that's really kind of the nuts and bolts of those pieces. One of them you may see, and I've talked a lot about it before, is that idea of a service level agreement. So that says, what services are you going to provide me for that contract? And you're very specific in there. So for example, with Blackboard, it's down to how many minutes a month are you going to be unavailable? How many users can you support? Those kinds of things. So service level agreements. So you may also see an MLA. MLAs are a little less common, but if we are using, for example, Photoshop and we want to build an extension to it, we would probably get an MLA. So in other words, they are granting us an agreement to market this third-party extension or something else. So these are some of the documents you're going to run into. And it doesn't matter if you're in IT or in business, you're going to see that RFP licensing. So once we create that contract, once we create things, then we have to figure out how do we manage changes in it. And that's where it gets a little icky. And this is really where people tend to fall down because we think, oh man, we got a software patch, let's just go rush out and throw it in. And again, it's the easy thing to do. We say, all right, we're going to do updates, we're going to replace parts. We already have the original network plan. How do we change that? Do we go in and change it? And I will tell you, the number of places I've been to where we had an original network plan that's never been updated, never changed, but yet it bears no resemblance to the original is pretty shocking. So software, we have a couple of different ways we can do it. So there is something called a patch. So software, usually a patch is a small piece of code that's designed to fix one issue or one small piece. So if we have an upgrade or a service pack, maybe sometimes they'll call it in Windows parlance, then that's a major change. So there's a lot of different changes. So when we went to that ribbon interface on Windows, the operating system, that would be kind of an upgrade or a service change. If we just update it so that Excel calculates numbers right because it couldn't add 3 plus 3, that would be a patch. So there's a term that you often see though, because unfortunately those don't always go right. And so we try to fix one issue and sometimes we create others. And so we almost always want to have some way to roll back or go back to our previous state. So if something doesn't work right, we have a quick way to go, well, we were 90% functional, let's go back to 0.1.1.1. So you may also see the terms downgrading or back leveling. There's a lot of different terms. So sometimes we have to roll back things like our entire computer back. There is still a lot of corporate software that is not Windows 10 compatible. So we'll buy a new computer with a Windows 10 license, and we have to roll it back to Windows 7 to make that software work. So anytime we go backwards, we usually call it rolling back. So on the corporate environment is a little different than our personal computer. On your personal computer, I'm going to say, you know what? Windows updates are great. Go ahead and get them done because you're probably safer that way. But if you wipe out your own computer, you're not wiping out an entire network full of computers. Generally on a large network, we take changes, any of them, pretty seriously. We don't allow updates. So we'll try a patch out. So we'll probably have some kind of a sandbox system, or we may use virtual machines to try things. And we'll say, all right, so we're going to do these updates, and we're going to try them for a little bit, and then we push out that update when we think we're ready for it. There hasn't been any issues. We've tried it on all the software we use, and we push it out on our timeline versus Microsoft's timeline. So we get a little more proactive. Does it work? Does it make sense? Does it affect any of our users? Maybe we need to come out and do something else. So we have that ability when we're connected to like that active domain that we can stop software updates to a degree. We know that sometimes we need to push out those updates, that they solve a very valid business model. But if they also make all your computers go to just a blue screen and you have 500 employees just sitting there staring at their computer because you allowed an update through, yikes. And it gives us that little bit of granular control. We can schedule, in some cases, parts of those patches and different updates. So home and our business are a little different then. We can also a lot of times schedule these things off hours at other times. So we try to maintain and monitor those things a little more closely on the corporate side or the business side than we do at our house. So some of the things we always want to do, if we're going to make some updates, we're going to notify personnel. So if we're going to update the phone system and it's going to be offline, we need to notify a lot of people. It may be, if we run an operation that requires a 24-hour phone service, we can't do that immediately, that we're going to have to run ads in newspapers, provide an alternative phone lines, and those kinds of things. So sometimes these changes we think are pretty minor, when you look at your organization, may be very major. So we always want to make sure we back up and have some way to get our system back to its previous state. So we're going to keep users out, so we know that we have some way to lock them out. So a lot of times if we're a normal operation, we do these things at night. So one of the bad things if you're on the IT staff, a lot of times you'll be asked to do work after 5 o'clock or whatever the normal end time is. And that way you can do stuff when other people aren't there. So you'll implement it. You'll see if it works on the live system. You've tried it on your test systems. Now you implement it on your live system. Does it still work? If it does, and you want to keep that, then you go ahead and notify, hey, yep, we updated, let's move in, and you guys can update. So one of the things that's very important then is whatever change management system you're using, whether it's just a notebook or whether it's an a software-based change management system, that those changes get recorded. What happened? Why did it happen? Why did we roll back to a previous version? What went wrong? So all of those details are in there, so we don't go out and do the same mistakes twice. So there's that great statement about those who don't know history are doomed to repeat it. Well, if you don't know that a Microsoft Windows patch broke your ERP system, maybe it broke SAP and you can't send payroll out, then you're going to have an issue. So we almost always have an exit strategy. How do we get back out of there? So we will figure that out. How do we get back out? We may end up having to work. So if it's our ERP software we're updating, we may have to work with that vendor and say, you know what? We're going to update. We're going to update at this specific time. Do you have a plan for us to get back if we need to? So that's where those backups, and in this case, what we call bare metal backups, where we could go back to that system, come into play, and we do that a lot. So depending on what software it is, sometimes these upgrades can be interesting, scary, dicey. So a couple of things we have. So if it's an operating system, we've backed up the whole system. We can uninstall, reinstall it if we need to. If it's a system patch, generally we can uninstall those. If it's client software, you may have to use whatever tools they have available. And the reality is sometimes those don't always work as well as you'd like. So be prepared to use those backups. Or if you're using virtual machines, you can create snapshots and go backwards if you need to. So this is very true, but I don't think it should be. So the larger the organization, the more documentation required. And so if we take that down to a small business, what that really means also is, unfortunately, with a small business, nothing's required, nothing gets done, and we end up with a willy-nilly batch of machines. We end up with software that's patched and unpatched, and in a lot of cases, nobody understands what's going on. But in a lot of companies, you really have a very formal process. You're going to submit a change request, and most of these times, these are electronic now. But you're going to follow whatever process they've set up, provide any ending documentation after it's done. So every change has a fairly well-developed paper trail. And I call it a paper trail, but we know it's really done electronically. And so we try to come up with what's going to happen, how is it going to happen. And so if you went into IBM and you just started updating computers, you'd probably be fired the first day. All right. On Wednesday, I think I'm going to finish up this chapter. So make sure you've read the rest of chapter 12. What I want to look at really quickly is to get you the first head start on it, is what do we have left to do? So week 16's assignment, I know you guys all have projects and other things going on. So I said, let's just skip the project for this week. Unless you guys object. No objection. All right, great. So there is a quiz. There's last year's and there's this year's videos that will be available. There is a quiz and there is a discussion board. And that discussion board this week is I really want feedback from you guys about, if I can get there to click on it. So I want a discussion board and I want to find out what you guys, how do I best get all this knowledge into your head? There's a ton of stuff. Quite frankly, one of the things I would love to do is have this class split into 2 classes, but we already are pushing the limits of what we can have in terms of classes to shove into your degree program. So what kind of things worked well? I will say that Lab Connections, now I will say they also promised that it would be ready for fall, and it's not. But it's coming out with something that is an alternative / better / whatever than the Lab Connections. It'll be more interactive. You'll get to interact with servers and do some pieces that we don't get to do now. So my hope is the Lab Connection will be much better, and it supposedly will now be able to integrate directly into Blackboard. So grades will go into Blackboard as we send them through. I've heard that before from publishers, so I will not hold my breath on it. We'll see if it actually happens. But what kind of things? So be brutally honest. I will not, penalize you for anything in here. The other piece I want to look at is there is a small portion of your final that is take-home. So if you scroll all the way down to the final, there is a small portion here that you can do ahead of time. So that is an assignment link. So you can do that ahead of time before the final. It's worth 10% of the final. So it's not just subnetting. So there's a couple of different pieces. So we look at, I took out all the subnetting questions. Blanc. There I gave you a tutorial, and you need to actually read it. And so then there's 5 different questions, or 4 different questions and an instruction. Make sure you read the instructions carefully. So on step 4, make sure you do both videos or find both videos. So I'm always looking for other materials. So a lot of that stuff that we present and I show you guys in class or I make links to is stuff that you guys have found. So this is also due prior to midnight on December 13th. So it sounds like it's a long ways away. It's a week from Wednesday. So your final then, you have 2 hours to complete, and it is not available until Tuesday. So Tuesday at 12:01 a.m. it pops open. So it's available Tuesday and Wednesday of next week. That's it. So make sure you note those dates. I will send out announcements and reminders, but make sure.
Is that MindTap stuff going to be in the gradebook before you take the final?
No, the MindTap will also be, I will pull the grades out of MindTap that same day, probably at midnight. And that way giving you guys the maximum amount of time. So that is an online piece since we have a mixture of students. So you can take that. You are certainly welcome to take it. I'm not sure what our final is right off the top of my head scheduled, but I think it's 10:30 to 12:30. But you are welcome to take it on campus, or you can just take it online during that 2 days. So lab connections will also get pulled that night. So remember, there are 300 points available for lab connections in total. So there's 1,000 points in the class. It's 30% of your grade. You can take lab connections an unlimited number of times. So if you have a lab, you can repeat it an unlimited number of times. What I do is I then take your percentage that I calculate, not the percentage calculated inside of lab connections, because that percentage that it shows you is a running total. So if you only did one assignment inside of lab connections, it's going to say, hey, you have a 99%. And maybe that's what you got on the one assignment. But if you add in all the zeros for the other 9 assignments or however many there are, it's going to lower that. So I pull that into Excel and calculate it that way, so I make sure that I have the correct number. So whatever percentage you have then goes into that 300 points. So if you had 99%, that would be 99% times 300, or 297 points. Now, I do generally grade up a little bit in terms of like 5-point or 10-point chunks, because I know there are a couple of assignments that people had some weird technical difficulties with. So if you had a 99%, you're probably going to get all 300 points. If you had a 70%, you'll probably get 270 points, or whatever the number happens to calculate out at. So I do tend to push them up just a little bit, but not a huge amount, to make up for those. Because one of the weird things in lab connections, I can't go in and fix an individual assignment inside of lab connections. It's kind of an oddity. I don't have that level of granularity in the grading. So I will send out a big announcement on this to reinforce it, but I wanted you guys to have as much time as possible and take a look at that, and to start on your take-home assignment. So since we had that, that's kind of my pulling the assignment piece back out. So the only thing you really have due this week is your quiz and the discussion board. Any questions? Anybody ready for finals? Anybody ready for finals to be over?